discuss single phase voltage source inverter considering R and RL load. So first of all, we have to consider this R load and we have to draw the circuit diagram. This is a source. R load is connected over here. This is R load. This is one switch S1. Another source is connected over here. Another switch, that is S2. Let the source voltage is EDC by 2 for the first half of the circuit, and for the second half of the circuit the source voltage is EDC by 2. So at mode 1, say at t instant, t is between T1 and T2, this is the range of t, when this S1 switch is on condition. So the first half of the circuit will operate. So that time the circuit diagram should be like this: source, load, and this S1 switch, that is in closed condition, EDC by 2, R load. So the direction of the current should be this way. So when current entered to a terminal or to a junction, we have to consider positive sign, and when the current leaving to a junction, we have to consider this negative sign. So that means we are getting a positive voltage across this resistive load, across this load terminal. Similarly, at mode 2, when this S2 switch is on condition and S1 is in off condition, at an instant of T2 to T3, that time the second part of the circuit will operate. So the circuit diagram like this. This is R load, this is EDC by 2, and this second switch S2 is now in closed condition. So obviously the direction of the current should be reverse. That means in this way the direction of the current will flow. So across the load terminal, this is obviously positive sign which we have to consider, and in this part we have to consider the reverse sign. So that means we get a reverse voltage across the load terminal in mode 2. So what will be the voltage which we are getting across the load? If we draw this voltage, output voltage across the load terminal with respect to t time, then we are getting a pulsating AC voltage at an instant T1, T2, T3. Okay, so this is say T1, the initial state, this is T2, and this is T3, and so on. So for first T1 to T2, we are getting positive voltage across this load terminal, and this is a 1 pulse voltage which we are getting across the load terminal. Similarly, at instant T2 to T3, we are getting reverse voltage across the load terminal. So what should be the magnitude of this output voltage? Obviously EDC by 2 in positive half, because the source is EDC by 2, and for the reverse half we are getting EDC by 2. So this is the output voltage across the load terminal which we are getting. Now we are considering single phase voltage inverter, single phase voltage source inverter with RL load. Circuit diagram should be same. So this is a source voltage, this is RL load, this is one switch S1 is connected over here, and this is one freewheeling diode, this is D1, EDC by 2, the supply voltage. Similarly, here also EDC by 2, the supply voltage. This is another switch, that is S2, and diode D2. So at mode 1, when this S1 switch is on, at obviously T1 to T2 instant, then the direction of the current should be just like the previous one, this switch is on, this is S1 switch, this is the direction of the current. So obviously across the load terminal we are getting positive voltage. But as the load type is inductive, so that means in positive half, whenever the current will flow through the load terminal, inductor will energized. And after this mode 1, in mode 2, when this S1 switch is off condition, though the S1 switch is in off condition, but as per the energized inductor, it will dissipate this energized current through a freewheeling path and through this freewheeling diode D2. How? This is RL load. So this is positive negative terminal. This is the source. This S2 switch is always on off condition right now. So S1 and S2 both the switch are in off condition. Only diode D2, if we consider diode D2, this D2 diode is in forward bias condition. So this energized inductor will dissipate this energy through this path. Next, at mode 3, this is instant T2 to T3. So at mode 3, instant T3 to T4, when this S2 switch is again on condition and S1 switch is off condition, that time the second part of the circuit will operate. Obviously, this is RL load and this is the switch. So the direction of the current should be this way, ADC by 2. So we are getting a reverse voltage across the RL load terminal. This is S2 switch. Similarly, as we had discussed in previous case, that L is inductor, and due to this inductor, energized current will flow at mode 4. When all the switches are closed, S1 is off condition and S2 also in off condition. That time, due to this energized inductor will dissipate this energy through another freewheeling diode, and that is nothing but D1. Because if we consider this load terminal and the sign, then we can see that D1 diode only in forward bias condition. So the first part of the circuit will operate and the direction of the current should be from load to D1 to source to this way.